Now, our last speaker today comes again from the EuXFEL facility here at DESY. He's working in computational physics, physicist and working in computational physics, and he simulates the imaging of molecules using machine learning. So I expect that he uses machine learning to do all his work, because the machine then learns how to simulate molecules, if I'm right with that assumption, and if and how we can look at molecules by letting them explode. That's what Benoît Richard will tell us now. Benoît, please.
Do you recognize this music? I see some people cheering for it. It is from Lord of the Rings, of course, a very much beloved movie. And I want to take you to talk about it a bit today, because there is, in this movie, one scene that interests me very much. It is that scene in the first movie where people from all around Middle-earth are coming to discuss the fate of the world. And tonight, I would like to invite you all to join this council. So, imagine you have been invited and now you have gathered with all these great heroes from all races of the universe. And the great wizard, Gandalf, comes and shows you that ring, and he tells you, oh, look, this is an artifact of great power. It has absolutely imaginable magical potency. But we must destroy it. Because it is evil, because it is dangerous, we need to get rid of it. And of course, if you know the movie, you know that at some point there is that guy called Boromir that stand up and say, well, it's a stupid idea. If it's such powerful, such a great tool, we should really use it. We should not let it go to waste. And, well, obviously, I think Boromir is right. But I'm not quite totally agreeing with him, because I think he is not going far enough. If I was at this council, as you are now, I would say, well, the ring is great, but there is also this big eye. And as a scientist, what I see here is a big device that is looking at things. And as scientists, well, we are not evil, but we like looking at stuff. And that's exactly what Sauron is doing. And he is doing it in a way that no other creature in Middle-earth can do, that no other device in Middle-earth can do. So if we destroy the ring, we destroy Sauron, and we have just wasted a great opportunity. I mean, that's purely logic, nothing evil here again. And incidentally, we have something quite similar to Sauron here in Hamburg. And so this is a European X-ray free electron laser, and or European EuXFEL for short, and it has many, many things in common with Sauron. First of all, it looks similar, as I can show you, that they are essentially the same thing. But more importantly, for us, they are both basically used to look at stuff. Sauron looks at hobbits and humans and puny elves, whereas with the European EuXFEL, we look at molecules. Another great thing they have in common is they are unique in the universe. There are things you can see with European EuXFEL that no other device in the world can do. They're just Sauron is unique in the world of the Middle-earth. But there is one last very important thing about these two great evil powers, I guess. It is that they are too powerful. They simply are too powerful, because when you look at a molecule with a European EuXFEL, this molecule simply explodes. It is destroyed in an instant. And this is something many scientists are afraid of. This is a power many people like Gandalf would say we should not use. Rather, we should find some trick, we should think about something we can do to get our image without being affected too much by the destruction. I obviously strongly disagree. And I think we should really use all that potential from European EuXFEL, all that power to our advantage to get better image of molecules. So to explain to you how making a molecule explode can help us, I have bring here a deck of cards. Yeah, what is it? Now, imagine when you are looking at a molecule, what you want to do is to find the configuration of atoms, such as I could ask, well, I would like to know in which configuration are the cards here, so in which order they are in the deck. And if you look at it very hard, you will notice, well, you can not see it. You are too far away, they are too close together. But if you are Photon, when you look at it, what would happen is something like that. It would simply explode all around the place. And now, it's much easier to see that this card is different from this one. I'm sorry for the one on the back, you choose wrongly. But of course, you can see that, well, I basically just made a mess. And how can I use that to say anything about what I started with? Good things, I brought another deck of cards. It is in the same order, so in our experience it would be the same molecule, and we can simply repeat the same experiment. You look at it very hard, and it explodes. Very nice. And now, if you repeat that maybe 1,000 times, maybe 10,000 times, or maybe more, you will start to notice some patterns. You will say, oh, these two cards always end up close together. These two cards always end up far away together. And by throwing enough PhD students at it, by throwing enough computing power at it, you can simulate it many, many times. You can do it many, many, many times. And you can start to find this pattern and connect them to the structure of the molecule before destruction. Because a molecule being destroyed is something that has been measured. It gives us these very beautiful images of all the fragments. That's something we can really do. And my work in that is to look at them and try to find the connection between the exploded state with what we started with. And now, remember, you are at this council, and I brought to you these new techniques, this new idea that some would dub as a dangerous idea. And you may ask, well, why should we use this new idea instead of the old ones? What are the advantages of making molecule explode rather than what we have been doing until now? And the reason for that, why I think it's good and it's great and we should pursue it, is that currently for complicated molecules or for proteins, it can take years and large amount of money to image a single one. Because for each new type, sometimes you have to do device-specific experiments. Whereas if you give me enough powers and enough funding, I can, in principle, in device like European EuXFEL, we can make explode any molecule. And that's why I think you, very honorable council, should give me your trust. Because given enough time, enough funding, I think I can devise a method that will allow us, that will work with any molecule. In short, what I'm promising you, if you trust me, is one method to image them all. Thank you very much.
Benoît Richard.